And again, I like this idea because it combines the aesthetic function with the thermal mass idea. And very important. And again, like this home here, it's very very energy conserving house, this one, and they've done all the right things on the conservation side. And but here now they've gone up to almost 11% ratio of south window to floor area ratio, but they added the thermal mass in the floors to do this. And I just got an email from the Conrad Norbert, who's the owner of the house, and he's got that wood stove, but he promised that he wouldn't use the wood stove for the 1 year of monitoring that they would do on that, and it's worked quite well, and he thinks that they'll be very close to being net zero based on about I think 4 months of performance they have so far. This stuff weighs, concrete weighs about every cubic foot weighs about 140 pounds, and so you can't just keep adding this on a house, or you'll start bending your floor joists, or so if you're going to be adding more mass to a house, you've got to address it from a structural standpoint.
Is water heavier than concrete?
No, water water has a density of 1 kilogram per cubic meter, and I think concrete is about 2 kilograms per cubic meter, roughly. But it turns out actually on a typical wood frame floor, you don't have to add any additional rebar or anything in that. I think they put a little bit of mesh in the concrete, but the posts that are supporting the floor and the pads in the basement have to be bigger to accommodate the extra weight. Now, Ron, here's a memory test for you. You've done the simulations on this house. What is the passive solar contribution in this house? I would think it's around 30%, 35% on an annual basis.
40, but it's close.
Okay, yeah. But by going to the extra window area, they're jacking it up to 50%.
I was in that house that Rob just showed us
yeah.
on hot August afternoon, like 5 o'clock, and they didn't even have the shading up yet, and it was comfortable inside, and it was all from the thermal mass.
And there is the passive solar comparison. They've built and finished at least 3 net zero homes in Edmonton. There's the Riverdale net zero home, the Mill Creek one, which I showed you here, and there's another house called the Belgravia one. And on the Riverdale house, they were getting 38% of passive solar contribution, and the Mill Creek they're 50, and then they've gone to 55% here. And a typical home, every home gets a little bit of solar heating from through the windows. You know, it's maybe of the order of 10 or 15%. And this is an example here of a builder who's run with the idea of thermal mass and passive solar. So well, just in conclusion then, first, in our climate, we don't live in Southern California here, even though our building codes recommend the same minimum R values. But we have to start out with a very, very energy conserving design. Concentrate windows on the south wall of the house. Use the best windows available. There's a great old saying, fast, good, cheap, you're only allowed 2 of the 3. Don't cheap out on the windows, you can get the best. Use ideas for inexpensive thermal mass, you know, bricks or old bricks, or you know, scrap gypsum board. you know, load up the walls with that. And you can tell if the walls have anything in them because it sounds pretty hollow here. But these walls here, when I do that, it's a much, you know, different kind of sound to it. And that completes my talk there. And if any, I was going to just see here what the temperature is in the room here. Now, oh, you tried the two different walls here with the temperature. Yeah, with the better insulated wall now, this is reading 16.3 degrees Celsius here on the window surface. And then Ron put it on the R60 wall here, I guess. And it's 19.4. So the better insulated wall, of course, has less heat transfer through it. And I'm just going to so we started out about an hour and a half ago, I guess, at 20.6, and we'll just see here what the temperature is. It takes a while for these to. But one of the advantages of the thermal mass here, plus the free energy that we're getting off your bodies, is that you know, the house does not cool off very rapidly. If you had a standard house here with the same, you know, just 2x6 construction or something and inexpensive windows, you know, we would have had to turn the heat on, or people would be complaining it's getting pretty cold in here.
Keep in mind, we're also heating about 3.5 feet of crawl space underneath.
That's right, yeah, as well, we don't have any...
It's only got about an R24 wall, and
yeah.
There's nothing on the ground, there's no insulation on the ground, so when you see these numbers, this house will be even more efficient on a real basement as well as insulated. So.
Yeah.
You can feel the cool in your feet probably on the floor.
Yeah, that's the big heat loss right now is down through the floor here. So again, I think the thing is not to go, you know, the ideas are, you know, put window on the south side, but don't go overboard with it because, you know, you're going to have two problems. One, it's going to cost more, and two, you're going to overheat in the summer, spring, and fall. And again, if you can integrate, you know, the thermal mass with something that's already has to be in the, like you need, I don't think most people would accept plywood as a finished flooring material, you know, structural plywood. And I don't know, Ron, if you've done the numbers here, you know, these concrete tiles here, how did they compare with, say, putting ceramic tile in?
Well, if it would have looked okay, we'd be pretty happy.
Yeah.
But, you know, they just didn't turn out. The ones we ordered were really nice. The sample we had was really nice, so it got delivered.
Yeah, I saw a sample. There's one at the in the display in the Western Hall.
Quite nice, isn't it? That's what I bought.
Yeah. But these look like a Mark I version. Yeah. Yeah.
Rob,
Yes.
if you're retrofitting instead of building new,
Yeah.
what, so I took, if you're replacing the windows, I assume go with the good windows.
Yeah. Yeah.
And if you're redoing the flooring or other things like that, you could increase the thermal mass. What are the other, what would you suggest somebody do?
Well, be very careful, I think, about adding additional mass to an older home. You know, you know, this weight here, I think we were looking at 20 tons of additional mass on the Mill Creek House. I can't remember the numbers.
10,000 pounds here.
10,000 pounds, so that's about 5 tons of additional mass here. You got to be careful, particularly on long spans, and you know, your posts, your teleposts are designed for, you know, light wood frame construction, and you start adding additional mass like that, you know, you might start bending things. I'll tell you an example. We were doing some work on the first R2000 apartment building up in Whitehorse, and there was, I think, a 30-suite apartment building. And one of the tenants there was a retired librarian, and she decided, she just loved books, so she made her living room into stacks, and so she had books from floor to ceiling, and then, you know, they were only about 2 2 feet apart so she could get through there. And what had happened